All right, jumping into the back side of this paper, we're going to do the top half together and possibly try some examples down here independently and then review them together. But we do not need to do that box. You can go ahead and cross that out. All right, jumping up to the top here. If the measurement of angle WZY equals 145 degrees. Let's kind of pause there real quick. That's a lot of information. Even though it's kind of short, let's make sure we understand what they're saying. WZY. WZY. So it's this big angle here. So the measurement of WZY is 145 degrees. So that whole angle is 145 degrees. All right, let's go to part 2 of this. The measurement of WZX equals this expression, WZX. So it's this part here is 2x plus 10. And I'll try to type that in here or write it in here. 2x plus 10. And the measurement of XZY is again another expression, 4x minus 3. So we'll type that in here as well. And find the measurement of pretty much both these angles that we were just talking about, but they don't want an expression. They want just the numerical value. So we're going to use our angle addition postulate there, saying that we add these two expressions together, and that will equal the total angle here. These two parts added together will equal the total. So let's go ahead and add those 2x plus 10 plus 4x minus 3 equals the total 145. All right, make sure everybody's got that there. And now we need to go ahead and combine our like terms. Hopefully we notice that we have a 2x and a positive 4x. Together that would equal 6x. We also have a positive 10 minus 3. That would be a positive 7. And we're still up to that 145. So that simplified that side already a lot. Looks a lot easier now to go forth. Let's go ahead and do the opposite of plus 7. Would be minus 7 on each side. Give me 138. And these zero out, leaving 6x. Last but not least, divide each side by 6. A little calculator help. And we got 23 for our answer. And then it goes, are we done? And you're like, yeah, we did a bunch of work, right? But no, we did not answer the question. We have not solved for these angles yet. So let's go ahead and substitute that 23 in. And we'll have these calculators in everybody's hands surely enough very soon. As you'll see, kind of this helps expedite our process here. So 2x plus 10 would be 2. Then open parenthesis, I'm going to substitute in the 23, close parenthesis, plus 10. I get 56 for this one. That's yellow. I had 56. Wrote on there. And let's go ahead and do the 4x for open parenthesis 23, close parenthesis minus 3. And I got 89. So let's go ahead and write that down here. Oh, just put my degree symbol on there. All right. And if I add these two angles up now, if this postulate is true, which of course it is, so let's make sure I did my math right, it should equal 145. 56 plus 89, and it does. We get that 145 there. Let's keep it moving. Nice. All right. And bing, bada, boom. Where are we? Right about here. All right, filling in the blanks. Two angles are congruent if they have the same measure. Write that down. All right, that makes sense. Congruent angles, so that's a definition, congruent angles. And we know that congruent is really just kind of means equal, but congruent also just kind of means a little bit better than equal. It means like exactly the same. They're congruent. All right, let's keep it going here. We have one more fill in the blank, and let's go ahead and do that. An angle bisector. So one more vocabulary word. This is an important one. You'll see this on your module test coming up next week. An angle bisector is a ray that divides an angle into two congruent angles. Let's go ahead and write a statement here. So if ray BD bisects angle ABC, then angle ABD let me rewrite this here. Angle ABD, should be using a pencil, is congruent to angle DBC. So let's make sense of that, all that real quick that we just wrote down. So if ray BD, and here's our ray BD, so we're saying it bisects, so this is a bisector. If it is, which we are calling it, yeah, it is a bisector, it will split up angle ABD. Angle ABD will be congruent to angle DBC. Angle DBC. And another way that you'll see this coming up very shortly is if angles are congruent to one another, that they have the same angle, they'll have a dash to represent it. So for instance, one dash here and one dash there will show that those two angles have the same measurement. And we'll start to see that those dashes more frequently here in the near future. All right, guys, great job. We're going to tackle these last few questions together in class.